String reversal. It could very well be that the x-axis align break purple. The target is awake, take this. Ah, thank you, Finstar. You figured it out for me. Dot ole. Yadat uye era whoa. Ah. Haha. Okay, now seriously. For each 0 terminated string in the inbox, reverse it and put the result in the outbox. Okay, so we're basically going to be building a stack in our registers. Let's see what the length of our longest string is going to be. Looks like it's going to be only 3 to 4 at most, so this should work just fine. All right, so we'll designate basically a row of registers as positions in our string, and then we'll just walk backwards through them. So we count up and we count down. All right, so we're gonna inbox a value, copy it to one spot, or copy it to the address stored in 14, basically. And this will be a counter, so we just count it. After we copy it into a space, we add to it, and then we go over to the next space and stuff like that. All right, so we need to change the value to be 14, and we need to change it to be a relative addressing mode. And then after that, we bump 14. Whoa, you can bump relative. That's weird. Huh, neat. That might be useful. I have no idea if that's useful or not, but it might be useful. So we'll be incrementing pointer values at some point, or we'll be incrementing what a value points to. Yay, pointers. They were fun in C, they're going to be really fun in this game. So our next thing we want to do is we want to test if 0. So if 0, then we jump back to... If it's 0, then we need to step back and then pick everything up. So in that case, we copy from what 14 is pointing to again. And then we bump 14. No, we need to outbox it. Then we decrement it. And then we jump back to the start of our loop. No, we keep doing this until 14 is 0. You can use an arithmetic trick to determine the middle value. Okay, I think you guys are talking about a different puzzle than this one. All right, so this kind of works. I don't know. Again, allergy haze is making this a little bit harder for me to do. That's not the important thing. The important thing is that we've copied from that outbox the value bump. And then, when we hold bump, if it's 0, we jump back. We do one more outbox, and then jump, I think. I mean, that because we need to jump from whatever is being contained here. So let's see what happens with this. This feels like it doesn't work, but let's see what happens. So we put down H. This is just me. I'm doing this just to kind of test to see if I've got this the gist of it down. I, again, feel like this is not quite correct, but that's fine. Whatever bugs may happen, they'll just happen, and that's how we'll work with it. So we do 3, and then we throw it out. We pull out a 0. We load that out, and that's not correct. We don't want to put a 0 in the first place. So when we've done this, we're copying from... Let's see what happens again. I want to step back with the debugger. So this first part is correct. We've loaded things into the spots that I want them to be. So then we put in 0, and then we're doing this copy from what 14 is pointing to, which is wrong, because the very first thing that we actually want to do is decrement it. So we'll bump that down, then copy from it, then outbox it. Then we need to copy from... If it's 0, then we just jump. Well, okay, there's still another bug here. I know of it, but I don't know quite how it's going to play out. So I'm going to let the bug happen, then we're going to figure out what the solution will be. But I know that there's some way that I'm either outboxing one too many times or not enough times. So we put down 0, we grab that. You can't jump if 0 with empty hands. Ah, that is the issue. So we need to, if I put the jump if 0 here, then that's not right. But if I do jump if negative, that might do it. We bump it again, and then we jump back to the start of our program. I think this is the correct approach. You need to dispose of the 0. You don't want them outboxed. Yeah, that was sort of the issue. Okay, so we put down that. So getting this string copied into our registers here is correct. And that's all fine and dandy. So then we grab the 0, we throw it away, we bump down 3. So we bumped just this correctly. I did this really, really wrong still. I'm still doing this super duper incorrectly. So this is not really hard, I just am dumb. So I'm gonna run it and then debug it. Okay. God damn it, I keep pressing stop when I want to press this button next to it instead. Alright, so our issue is with my loop statements here. So we've loaded up. Okay, this is from where we've grabbed the 0. So we hold the 0, we jump if it's 0 over to decrementing 3 down to 2, which is correct. And then we grab our 0 here. We outbox it. And then I need another jump statement. That's all. Easy enough. So then we just jump back to this decrement operator here. Okay, so I just wasn't looping at all. Okay, so we put down true, and then 3, 0, E, we grab 2. There's still another bug, and we're about to run into it, I believe. We grab T, we decrement it, we put it back up to 0. Never mind, this works. Okay. Cool. You'd love to see how they created these puzzles. Did they create a piece of code and work out the results, or did they actually try to code an optimization for the puzzle? So it's not too, like, I think that these puzzles are harder to do than they are to conceptualize, if that makes sense. Like, a lot of these things are pretty straightforward, like coming up with the solutions for them comparatively, but it's then that they had to translate it into their weird video game version. So like you can easily just like program a lot of these things in C and then run it through GCC or something to get the machine code representation of it in x86 or something, and then you just have to translate the x86 into this, which is, all things considered, not actually that hard. But I mean, if you wanted to, you could actually just cheat like through this game by doing that exact process. Like if you already knew C but you didn't know assembly for whatever reason, you could probably just do it that way and then just kind of figure out a system for translating the code from x86 into assembly. But that would be really, really boring, so that's not what I'm going to do. Inventory check, accounting verification, surprise, Audi. These are many of my favorite things, so let's get started. For each thing in the outbox, for each thing in the inbox, send it to the outbox. Send to the outbox the total number of matching items on the floor. So for C we would want 2. For X we want 2. For B we want 3, 4, 5, and for A we want 1, 2, 3, 4. Okay. So if I wanted to, I could probably like pre-compute all of the values based on their first appearances here. No, okay. Well, A surprise Audi, you have to assemble a car. Yeah, you heard what I was saying. Anyway, yeah, I wonder why people are always afraid of IRS Audis in the first place. Like, I think that would be awesome if the IRS were to send me an Audi notification. Alright, so there is no reason to pre-compute this because we have to look at every value. Well, if we do one step through and then construct counters for each of them, but then how do we reference those counters from so for C, there's a way to really weirdly optimize this that's probably not worth doing. So we're going to go for the dumb solution first and then worry about it. But right now, the obvious solution to me is that I look at this input of C, and then I look through all of the data, and then for every C, I increase this counter, which is fine. Or I increase a counter, I should say, which is fine. But then when I do X, I have to look at everything again, which ends up being a lot of wasted effort. So if I were smart, what I would do is I'd walk through this list once and then say, this is a B, therefore whatever value I have corresponding to B, I will increment. Whatever value I have corresponding to A, I will increment. Whatever value I have corresponding to X, I'll increment. So I'd have 4 values down here. One for A, B, C, and X. The problem with that approach is that I have no idea how to map a C to the counter for it. I don't think I have that capability without, like, a little bit more memory. So yeah, I don't see how to do that, but it would be considerably faster. So we're just going to do the walk through the list method for now. So very first thing we do, we inbox the value, and then we need to construct a placeholder register. We'll call this 0, and then this will be count. So we copy from 0, copy to count, and then we also need to keep track of one other thing, which is we need to keep track of an index, so where we are in this list. So we need to copy, we don't need to do that, actually. We just go until we're holding a 0 tile, because we're going to just scan this linearly. We do need to do that, because we need to increment, we need to keep a counter somewhere. So we do need an index somewhere, because we need to keep moving linearly through all this. Alright, so that's fine. Let's go ahead and copy from 0 into, we'll use register 19, that's going to be our I. Alright, so we copy from 0 into I, and then we're going to copy 0 into our count. So we're going to inbox, then we grab whatever letter we want, and we're going to be jumping back into this point eventually. So we inbox C, and then we copy from I relative, and this value will represent which cell in this array we're going to be looking into. Then we bump it. We bump I. And then once we do that, we need to start doing our tests. So if we bump I first, okay. We'll bump I after we do our test. So if we copy from I, we then test if it's equal to C. Whoa. We don't have the ability to test if it's equal to C. What the hell was I thinking? If I subtract C from C, though, will I get 0 and then I'll be able to jump? Hold on, what am I doing here? How do we test equality between these two numbers? If I ask for Huh. Yeah. There's something weird about this that I'm not quite seeing. How do I test for equality between two letters? I guess I subtract them from each other, and if they're 0, then that equals the ability to jump if 0. Maybe I'm overthinking it, but that's what I think it is. I don't know. Let's see what happens when I just do this run, because I want to see what happens when I attempt to subtract. Did I do a copy from? I meant to do a copy to. So we do a copy to I here. Okay, let's just... I want to see what happens when I attempt to subtract a letter from another letter. So grab A, and then I bump 1. You can't sub with mixed operands. Subbing between one letter and one number is invalid. 2 letters or 2 numbers are valid. Okay, that's correct. So we bump... So we're gonna... We'll worry about bumping later. We're just gonna do subtraction right now, just to see what the result of it is. But I believe that if you subtract 2 numbers together, you should be holding 0. Which is perfect, which actually makes a lot of sense. Okay. And then, now we can continue to set up our loops correctly. So, if on subtraction it is 0, then we need to do a... We need to increment our counter. So if it's 0, we bump count, and then we jump back to the top of our loop somewhere. Let's go ahead and comment our code. This is init. This is loop. Loop C for loop condition. So our loop condition is if what we're currently holding is 0, then... Alright, so we need to also make sure that we stop iterating this array once we reach this this value over here. So we are holding that value, so we need to copy from... We're holding C, or we're like holding X, which means we need to store X once we do subtractions from it. Jeez, wow. Okay, so we need also a letter variable that we need to store things in too. So when we inbox something, we copy it to the letter. Wow, this is crazy. This is a hell of a function. Alright, so we stash our letter somewhere. And then... we need... So that's also part of initialization. So then we need to... We're currently holding the letter at the start of this loop. So we need to copy from... We need to subtract relative to whatever is stored in I. So this should grab, like, X or whatever, and then subtract it from, we'd subtract B from it, and then and then we'll be holding a value, and that if that equals 0, then we need to bump what is stored in count, and then jump back over here. So if it's not 0, then we just don't bother. We just don't bother to... we just jump over the count statement here. But otherwise we need to bump our I here. So let's see what happens. This is for the night. No, I don't think so. Definitely not. So that's 22. That's not correct. So we bump I. We copy from I to get A. No, we need to also then copy from... After we need to copy from what's contained in our letter first. Alright, so we're still currently not outboxing everything, so we have no output with this function. But I want to see if we can just build the counts correctly. Because then, once we build the counts correctly, it's fairly trivial to see what we need to be doing. So we pull out x, we subtract b from x to get 22, so we don't increment our count. We then grab whatever is stored in 1 to get 23, increment that to get whatever is stored in 2, grab x, subtract x from x to get 0, so then we increment our count, and then this all looks correct. This all looks very much correct. We're just not doing any output right now. So, when all is said and done, so right back up here at the top of the loop condition, if what we're holding, oh my god, okay. Normal programming is far, far easier. You probably pulled most of the problems in this game using one line of Python. Very true. Very true. So we're subtracting immediately from what's stored in here, which is a bad idea, because eventually we're going to have to see if what we're holding is 0, because that signifies the end of this big list. Great. So I need to get rid of this relative addressing thing. I need to copy from whatever is being held in I. And then if that's 0, then I jump all the way down here, copy from count, outbox it, and jump back to the start of everything. Otherwise, we need to copy from letter, subtract from what I is pointing to, and then do it this way. This should work. So we should get 2 from this. And this is god-awful. Okay, so we have 0, we put 2 in there. Okay, we did it. Wow. This was, in no uncertain terms, pretty hard. Pretty hard. This kind of combined our idea of a null-terminated string that we talked about a little bit earlier by putting 0 at the end of a big array. And there's just no way that this was the efficient solution, unless it comes up the optimization and it's like, you know, you did this in 4,000 steps. That's way less than what we expected, or something. I would be very, very, very surprised if that were the case. But there we go. Let's see what the size challenge was. Well, no. And speed challenge, 393, 491. Well, I did it. But there you go. Cool. So let's see, where's Carol? Let's find out.
Hey, where's Carol? Oh my god. This coffee is amazing. Back to work, ladies.
Breaking.